Hello everyone, my name is Yong-Soo from Pukyong National University in Korea. Today I'd like to present about Moscow CNN-based environment invariant reinforced soil retaining wall monitoring technique. So let's start. This is my content from introduction, experiment and method, results and discussion, and conclusion will be present. What is the reinforced soil retaining wall, simply called RSW? Henry Vidal was firstly suggested in 1969. At first time, a concept was wide steel strip connected to the metallic spacing to increase bearing capacity and friction in soil particles. Nowadays, geosynthetic were widely used as a reinforcement that makes a one structure that with backfill and soil. As follow the left figure, amount of area of RSW is kept increasing after 1990s, and 150,000 of RSW have been filled in worldwide. This slide shows safety inspection method of RSW. In Korea, regular inspection was conducted with different importance of structure or size of structure. It means that it cannot always ensure the safety of structures with unpredictable hazard. That's why we need real-time monitoring system. To solve these problems, there are some of the researches. However, they just focus on one spot, not a whole structure. So they cannot ensure a safety of whole structure. So that's why we need monitoring system to control whole retaining wall structure. The method we used in this study, named photogeometry, that means find geometry by analyzing photos. Several inspection methods has been used. However, photogeometry has strengths for each part, especially speed and instrument costs. Image-based monitoring system is mainly used in this study, and real-time monitoring for whole structure can ensure safety of structure and public security with video recorded 24 hours. This slide shows difference of the single camera system and the stereo camera system. As you can see at left side, when there are P1, P2, P3, and P4 in three-dimensional space, spatial unclear area, we call that gray zone, is occurred for P1, P2, P3 at the left viewpoint, and for P3 and P4 at the right viewpoint, there are gray zones. Therefore, in order to solve this problem occurring at the single viewpoint, analyzing images taken from two or more viewpoints called a stereocamera system is recommended for analyzing the three-dimensional behavior of structure. In this study, only the basic displacement and settlement were considered, so we can calculate the displacement by using a single view of the images, and those displacement types of retaining were defined based on the documents listed in the table. Through this, the behavior of retaining wall structure can be analyzed based on the image of the single viewpoint. As there is no spatial unclear zone area, gray zone, even at single viewpoint, or as shown in figure 8b. And figure 9 shows type of displacement type that is used in this study, and normal state and basic displacement, settlement, and combined displacement were considered in this study. Figure 10 shows the single camera system proposed in this study. The behavior of the structure can be analyzed through the geometric relationship of the distance between the camera and the structure, and the angle of incidence, and the camera parameters. The amount of x and y changes in the image plane is calculated as the y and z displacement of the rear coordination. This slide shows Mascar-Shannon. We used Mascar-Shannon to track the behavior of blocks in RSW. Mascar-Shannon is one of the methods to do the instance segmentation as shown in figure 11 and above figures. We can easily say, detect the pixels of object in the image. So, people, trucks, and blocks could be detected from the Mascar-Shannon. Mascar-Shannon was developed from her 2017, and that is based on the Bessar-Shannon, which is the popular object detection method. Figure 12 shows the experiment setup, and we used total station to take a rear and reference displacement at each ROI. The table shows specification of materials that is used in this experiment. Phasing displacement and settlement alternatively occurred in a normal state for a more complex behavior than previous research. The performance of matching and displacement calculation for each target were evaluated, and the performance were compared to validate 5 artificial target and 5 natural target. Figure 14 shows the experiment setup for with different illuminance, and total station is also used to take a reference displacement at ROI. Figure 15 shows the daily illuminance distribution, and the illuminance were normally counted as 0 or 35 at the night with different condition of the light. And the important illuminance based on 35 lux, which is the case of night lightning, and 500 lux, which is the general illuminance of office. As in previous experiment, matching and displacement calculation performance were evaluated for artificial and natural target. Illuminance was adjusted by fluid light from the darkness condition to typical office condition. The camera was automatically adjusted for each illuminance so that the images were captured with the optimum brightness. The illuminance ranged from 1 to 500 lux. This is one of the result of the detection from mascara CNN for laboratory experiment. We detect every blocks, and there's some misdetection, but the result is quite good, and original image and ground truth and predicted mask are agreed well except blocks in edge. So this slide shows the detected images and precision, recall, and F1 score, which evaluated the performance of detection. And precision, recall, and F1 score shows a high accuracy of over 91%, and the error is also excellent with less than 2.12 millimeter regardless of displacement steps. In MRE, 8 artificial targets showed poor block detection performance due to the sheet target, and natural targets showed relatively excellent performances. This slide shows the result of detection, original image and ground truth, and predicted mask agreed well except blocks in the edge, especially light side. Maybe that because it is too small to detect as a block, so precision, recall, and F1 score shows high accuracy of the over 93%, and the error of RSW excluding edge block is distributed within 1.69 millimeter. So considering that most large errors are caused by detection errors at the edge of the RSW, the maximum error is reduced to 1.69 from 2.54 millimeter if this is supplemented. This is a conclusion. In the laboratory RSW experiment, the error increased due to the difficulty of estimating the transformation matrix as the displacement step increased. However, the error was still distributed within the 2.12 millimeter. In the experiments with different illuminants, excellent behavior analysis performance is shown with errors within 2.55 millimeter and 1.68 millimeter when remove the blocks in the edge section for the spacing displacement. The block of the RSW are sufficient to use as a natural target. It can be used as a targetless reinforced or retained behavior analysis technology when individual limitations are supplemented. Thank you for your attention. If you have any question, please check my email. Thank you.